I'm here to talk to you about the two worlds of cell isolation. In science, we're constantly faced with change. New discoveries, new facts, new paradigms. I'm going to talk to you about something you may not have realized about cell isolation and how technologies used impact immunology, results, and therapeutic development. This realization can help you improve your science, which is pretty good for all of us, but also may help you with a better chance of publications, authorship, and grants. So what's this realization? It's not that there is just one, but two worlds of technology when it comes to cell isolation. Two different planets. There is a nano-sized planet where particles we use are usually less than 1 micron, and there's a micro-sized planet where the particles we use are larger than 1 micron. Your view of cell isolation, immunology, therapy, and toxicology can be largely dependent on which planet you live on. While this is an oversimplification, there are many different definitions of nanoparticles in play, depending on technology, manufacturing types, and brands. But to simplify, let's look at Wikipedia's definition. Nanoparticles are sized between 1 and 100 nanometers. So here's the thing. The most commonly used product for cell isolation, referred to as microbeads, are actually only 50 nanometers. Therefore, they're not micro-sized at all. They're nano-sized, and they're not beads at all. In fact, they are random and irregular in shape. Confusing, I know. So let's just call them nano-sized particles, or nanoparticles. They kind of look like cornflakes. And since these nano-sized particles are largely comprised of iron and polysaccharides, you could say that they resemble sugar-coated cornflakes. So let's compare this to the micro-sized planet, where larger magnetic spheres, or beads, are used. Beads that are several microns in size, completely spherical, and highly uniform. Now, most of us live on the nano-sized planet of cell isolation. Why is that? There are three primary reasons. First, nano-sized particles, confusingly referred to as microbeads, were developed to be compatible with flow cytometry. So they quickly gained a following for this important application. Second, there are a lot of kits available. Third, it has the most applications. And as research scientists, you will not often get criticized for using technologies that others have used. For a number of years, cell isolation on the nanoplanet has been humming along. Scientists were happy, they were learning about cells, there was easy acceptance to publish. And until recently, this was all right. The main goal after you've isolated your cells is to identify and understand the different types in the human body. This is still important, but priorities have changed. Now we want to obtain cells as close as possible to their natural physiological state. So how does this shift impact your research? The technologies you use should have as little effect on the natural state of the cells as possible. And if the cell isolation technology does have an effect, then you need to understand what that effect is. However, there is evidence from the field of toxicology that nano-sized particles cross cellular layers and actually accumulate inside intracellular compartments, rather than being easily biodegraded. Indeed, this has been seen as a benefit when nanoparticles are combined with siRNA to become an efficient nucleic acid delivery system and a potential therapeutic. In 2006, Dr. Shenoy and his team showed that coating nanoparticles with PEG or PEG resulted in efficient internalization of nanoparticles in endosomes and cytosol, and they were found to localize in the nuclear region. Indeed, the coating of nanoparticles can be utilized for targeting. However, researchers at the Center for Biological and Environmental Nanotechnology at Rice University have found that oxidative damage to cell membrane varied dramatically with relatively minor changes to nanoparticle structure. And this leads to a number of questions. What's the impact as nanoparticles accumulate? How would cell physiology be altered? How about cell signaling? Is gene expression affected? So while toxicologies live on the nano-sized planet, they're in a different discipline than scientists doing all the cell isolation, which is like living on a different continent. But because the scientists doing cell isolation are in a different discipline and so remote, they keep using the nano-sized particle without being fully aware of what is happening on the toxicology continent. And so if nano-sized particles interfere with cellular mechanisms as seen in toxicology studies, then it's easy to understand that the same concerns also apply to cells isolated with nanoparticles. Back on the micro-sized planet, scientists using bigger beads see that they are more controllable. The beads could be added to and removed from the cells. Importantly, since the beads are larger than nanoparticles, they cannot easily be endocytosed by most cells. And if you want to isolate cells that are particle or bead free, if you really want to set your cells free, then the micro-sized planet is where you want to live. The bigger beads also have larger magnetic force, so the cells can be isolated more efficiently. Dr. Fossman's team from Harvard found that with smaller particles, the cells had to wait longer. And you don't really want them piling up on top of each other, getting starved from oxygen and nutrients. So she noticed a big improvement in the yield of cells when using micro-sized beads as opposed to nano-sized particles. In a short period of time, 100% of the cells are successfully isolated, and these cells have better viability and better purity. In other words, big is pretty good for cell isolation. So, here is where cell isolation is. 2 planets, one nano-sized and one micro-sized. Both have their advantages and disadvantages. Nano-sized particles have been highly published, and historically, this was the only technology that worked well with flow cytometry. But nanoparticles cross the membrane and have been demonstrated to impact cellular mechanisms. Micro-sized particles are not easily endocytosed, and the beads can be removed from the cells, and then the cells can be used in any application, including flow cytometry. Immunologists have recognized that cell isolation is a critical step to achieve reliable results. The technology used should have as little effect on the natural physiological state of the cells as possible. Knowing this, you might want to carefully consider which planet you want to live on.